Let's explore homologous series and their features. Homologous series are basically a group of molecules which have the same functional group. For example, if you look at all the alkanes, all these molecules have one thing common, that is they have a single bond. So we say that they have that same functional group, single bond, and therefore all alkanes belong to a single homologous series. Similarly, if you look at all the alkenes have one double bond. That's their functional group, same functional group, so they belong to the same homologous series. Same is the case with the alkynes. They have one triple bond, same functional group for all these members, so they're all part of the same homologous series. And you can have additional homologous series. For example, all alcohols, they have one OH group. And so all the members of this series are also homologous because they have the same functional group. In this case, the OH, the alcohol group. And you can have more complicated homologous series. You can have multiple functional groups if you want. But the point is that all the members will have the same functional group or groups. Now with that intro, let's explore some of their features. Well, one of the main features is that all members of a homologous series have the same chemical properties, but different physical properties. Why? Because chemical properties only depends on the functional group. Since they all have the same functional group, they should have the same chemical properties. This is amazing because this means if I understand how one alkene reacts with a particular molecule, I know that all other alkenes will react in a very similar way, giving me very similar products. That is amazing, isn't it? But of course, they have different physical properties. For example, they have different masses because they have different number of atoms. In fact, the mass keeps increasing. Right? Similarly, the melting and the boiling points also keep increasing as you go down. So the point is because they have the same functional group, they have the same chemical properties, but because there are different number of atoms, different number of bonds, they will have different physical properties. Let's look at some more features. So if I go from one member to the next member over here, you can see that the carbon atom increases by one. So there's one extra carbon atom, but there are two extra hydrogen atoms. So you have a plus CH2 when you go from here to here. What about when you go from here to here? Hey, it's the same. Plus CH2. Can you see that? That's wonderful. What about for alkenes? Why don't you pause the video and check for alkenes, alkynes, and alcohols as well? All right, let's see. So when I go from here to here again, you can see there's one additional carbon, but two additional hydrogens. So another plus CH2, and the same thing over here. And it'll be the same here and here as well. This is amazing. This means that when I go from one member of any homologous series to the next member, I will have to just add a CH2. If I have to go to the previous member, I just have to subtract CH2. Two consecutive members of any homologous series are always differing by just CH2. That's amazing. What are the features we want to see? For that, we're going to write a general formula for these three homologous series. We'll not worry too much about the rest of them, just these three. Let's start with the alkenes because I feel that's the simplest one. So you can see for alkenes, the ratio of the carbon and hydrogen, you can see that hydrogen is always twice that of carbon. C2, H4, C3, H6, C4, H8. So what would be the general formula? Well, general formula would be C-hen H2-hen. So this is the general formula for any alkene. What would be the general formula for alkanes and alkynes? Why don't you pause the video and give it a shot? All right, the way I like to see it is let me compare an alkane with a corresponding alkene. What difference do you see? I see that there are two additional hydrogen atoms here compared to the alkene. Same is the case over here. If I compare this and this, I see two additional hydrogens compared to the alkenes. That's because over here there's a double bond that is not there, which can accommodate two additional hydrogen, which means alkanes have two additional hydrogen atoms compared to their corresponding alkenes. So now how can I write this? Well, it'll be C-hen H2n plus 2. What about alkynes? Well, I can do the same thing. If I compare alkynes with the corresponding alkene, I see that they have two less. Here there is 4, there is 2. Similarly over here there are 2 less. There is 6, there is 4. So what will be the formula for this one? It's going to be C-hen H2n minus 2 because it'll be 2 less. And as a challenge, you can try to write down the general formula for alcohols yourself, but we will not be doing that. We'll only stick to these three. Let's look at some examples now. So if I ask you to write down the molecular formula for the 7th member of the alkane, what would that be? Well, it's going to be C7H, 7 2s are 14, plus 2, 16. Boom, we found that. What if I ask you to write down the 8th member of alkene? What would that be? Well, that would be C8H, 8 times 2, 16. But wait, that's not correct. And the reason for that is we need to be careful. For alkanes, the first member has 1 carbon, second member has 2, third member has 3. Very nice. But for alkynes, you can see the first member itself has 2 carbon atoms. The second member has 3 carbon atoms. Third member has 4 carbon atoms, which means if you take any member, it will have 1 more than the member number of carbon atoms. So if you take 8th member, it should have 9 carbon atoms, not 8. So don't get confused with that. So that means it's going to be C9H, 9 times 2, 18. What if I ask you to write down the 5th member of alkyne? What would that be? Well, just like over here, you can see the 5th member will have 6 carbon atoms because the first member itself has 2, remember. So it'll be 6 carbon atoms, and now it'll be 6 2s are 12 minus 2, which is 10. Finally, if I ask you to write down the molecular formula for the next member, we're just gonna add CH2 to it. So it's gonna be C8 and then add 2 hydrogens, so it's gonna be 18. Boom. And similarly, if I ask you to write down the previous member of this, you subtract CH2. So remove 1 C, so C5, remove 2 hydrogens, so C5H8, boom.